Okay, this video goes with the notes for 9695, angles of elevation and depression. So this is more like our 9596. And we start off just with some vocabulary, sort of like as an overview. So let's move on up a little bit. So they want us to underline the correct words. So when we talk about right angles, like a right angle is defined as exactly equal to 90 degrees. An acute angle has a measure between 0 and 90 degrees. So the measure of a right angle is greater than the measure of an acute angle. And an obtuse angle is measured as an angle bigger than 90 and less than 180. So a 90-degree angle is going to be less than the measure of an obtuse angle. And a right angle has a measure of 90 degrees. Lines that intersect to form four right angles are perpendicular lines. If we have two lines that intersect to form a right angle, by vertical angles, we can have another right angle there. By linear pairs, this has to be a right angle. And by linear pairs or by vertical angles, this other angle has to be a right angle. So all these angles are right, and that goes with these lines being perpendicular at the point of intersection. If we check out all these angles in the diagram, this angle ABD is a right angle. ABD, it's backwards here. And angle CBA is a right angle, since that's a linear pair. And CBA is this one here. These other angles are all acute angles. Let's move up. Now, the definition of elevation and opposite to that is depression. The elevation of an object is its height above a given level, such as eye level. Now, in our geometry, we're going to talk about the reference line for elevation as being a horizontal line. So if we're talking about eye level, this is like the eye here. Eye level is the horizontal line straight out from the eye. And an angle of elevation then is going to be the angle that you look up at from eye level. An angle of depression is going to be the angle that you look down at from this eye level. And we call this angle of elevation. This is angle of depression. So we're going to focus on the definition of elevation to start with. So we want to complete each sentence with the right word. So John elevated his feet on the footstool. The elevation of Mount McKinley is 20,320 feet. And you elevate an object by raising it to a higher position. That's how we would fill those in. Let's move up. Okay, here we are going to talk about angles of elevation and depression and how they relate to each other. So let me change colors up. Let's try gold on this one. See how gold works. Okay, so if you're an observer on the balloon, this line straight out is your line that's level with your eye. So this is our reference line for elevation versus depression. If we're looking up from this line, which is straight out, horizontal to the ground, we call this an angle of elevation. If we look down from this reference line, which is our eye line here, we call it an angle of depression. So this is from the point of view of the person on the balloon. Now, if you're the bird flying in the sky, its eye level, let me change colors up, its eye level or reference line is this horizontal line that goes across through here. So this angle 1 represents an angle of depression to the bird. So the way this, and let's get down here to angle 4 while we're at this. So if somebody's here at the base of the mountain looking up at the balloon, their eye level is this reference line here, and they're looking up at the balloon through this angle here, which to them is an angle of elevation. So let's kind of see how these things interrelate with each other. The bird looks down at a person on the balloon at some degree depression angle. The person on the balloon looks up at the bird at that same angle, but from the person on the balloon, it's an angle of elevation. And we can kind of see this going on here. Hopefully you can see this. If we talk about these reference lines here that go with the eye level for the bird and the person on the balloon, this line here represents a transversal with two parallel lines. And then this angle 1 and angle 2 must be congruent because they're alternate interior angles. And we know from past work that alternate interior angles are congruent. So angle 1 has the same measure as angle 2, which means that they're congruent to each other. But from the person's point of view, the angle up to the bird is an angle of elevation, and from the bird's point of view, the angle down to the person is an angle of depression, but they're both the same number. Same thing here for the person on the balloon and somebody that might be standing on the ground. They're looking down at the person on the ground through some angle, which we call an angle of depression to them, and the person on the ground is looking up at the same angle to the person on the balloon, but for them, that angle is an angle of elevation. So let's say the person on the ground looks up at the balloon at a 40-degree angle of elevation. This person on the balloon is looking down at a person on the ground at a 40-degree angle of depression. Let's say the person on the balloon is looking up at the bird at a 30-degree angle of elevation. The bird is looking down at the person at a 30-degree angle of depression. Because of the parallel lines with the transversal, these two alternate interior angles are congruent. Because of these parallel lines with this transversal, these two angles are also congruent. So let's see, angle 2, let's answer these questions. Angle 2 is above the horizon line from the person on the balloon. Yes, that's a true statement. Angle 2 is an angle of elevation from the balloon to the bird. Yes, that's true. It's an angle of elevation. They're looking up at the bird. Angle 2 is angle of depression from the, no, it's an elevation. And angle 2 is angle of elevation from the top of the mountain to the person in the balloon. That's more like the line of sight. That's not even an angle at all. That's false. Okay, let's do the fill in the blank part here. Describe angle 2 as it relates to the situation shown. Okay, angle 2 is an angle of elevation to the bird. So angle, let me change colors. It's an angle of elevation. Observer to bird. And it's an angle of depression bird to observer. And angle 1 is congruent to angle 2. So these two angles need to be congruent. As like angle 3 would be congruent to angle 4. Okay. So using this angle, let's see how we can do this. So you sight a rock climber on a cliff at a 32-degree angle of elevation. So here's the climber. Here's your eye level. This is the horizontal line that goes with your eye. You're looking up at a 32-degree angle to the climber. This is a 32-degree angle of elevation. So the angle of elevation is 32 degrees. From the problem or from the diagram, the distance to the cliff from the observer is 1,000 feet. And eye level from the wording is 6 feet off the ground. So I would actually kind of edit this diagram a little bit and add this part in here with a distance of 6. So the climber is so many feet above this horizontal line, which is represented by the opposite side of the angle in this triangle. But this line is actually 6 feet above the ground because we're talking about the person's eye level being 6 feet up. So that's kind of how the that's how the picture's going to look for this one. So we need to find the height of the climber from the ground. Now again, this is the ground. When we solve this triangle for this X side here, we're actually finding how high the climber is up from the person's eye level. We're going to need to add 6 feet to that to get the distance from the ground. So we want to find the length of the leg opposite 32 degrees by using tangent of x over 1,000. We want to use tangent of 32. And then we're going to add 6. Okay, so let's go ahead and finish this. We have tangent 32 is equal to the opposite, which is x over 1,000. So 1,000 times the tangent of 32 is going to be x. That's going to be how high the climber is above the eye level. And the actual distance from the ground, so d from ground, is whatever this x is plus 6. And it's going to be in feet. So you could use a table, look up a tangent 32, and multiply that by 1,000, which moves the decimal over 3 places, and then add 6 onto it to answer the question. Okay, let's move on. Okay, number 14, explain why you would use tangent 32 and not sine or cosine. Well, tangent goes with opposite over adjacent, and we want to find the opposite side, and we have the adjacent side. If we use sine, we would be looking at this. Well, sine would be opposite over hypotenuse. We need the opposite side, but we don't know what this hypotenuse is. There's not enough information to use Pythagorean theorem, so there's no hypotenuse number that we could use, so that knocks sine out since sine requires hypotenuse. And same thing with cosine. Cosine deals with adjacent over hypotenuse, but we don't know what the hypotenuse is. So what we do have, though, is opposite and adjacent, which goes with tangent. So that's why we have to use tangent for this one. So basically, this boils down to there is no hypotenuse given. Distance given. Or needed. So cannot use sine or cosine since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. Let's move on. The problem is solved below. Use one of the reasons from the list at the right to justify each step. Okay, so we're writing the equation. Tangent of 32 is opposite over adjacent. They're using D instead of X, where I used X. So that's solve for D. That's write the equation. And then we're multiplying both sides by 1,000 to get D by itself. So we're solving for D. And then we are taking the decimal of what tan 32 is times 1,000. So the decimal of tan 32 is 0.624869. We're multiplying by 1,000. Decimal moves over, so it's 624.86 or 624.9. And we use the calculator. Now that's the height from your eye level to the climber. 624.9 is about 600. Is about means around. So 624.86 rounds up to 625, so it's about 625 feet. Like 0.9 feet is about 10.8 inches, so might as well just call it a whole foot. The height of the rock climber from the ground then is 6 feet. Added onto this, it's about 600. He's about 631 feet because you have to plus 6 feet. Okay, let's look at problem 3 here. See if we got it. So here we have a situation where somebody in the plane is looking down at the raft at an angle of depression. And similarly, the person on the raft could be looking up at the plane at that same angle, but to them, this would be an angle of elevation. And this ground level here would be their eye level. This dotted line out here would be the person on the airplane's eye level. So down from that eye level, angle of depression, up from the raft person's eye level, angle of elevation. But both these angles are congruent to each other because we have parallel lines cut by transversal with alternate interior angles that have to be congruent. So let's fill this in. The angle of depression is 36 degrees. So we know by alternate interior angles, the angle of elevation from the raft is going to be 36 degrees. Now, see, this angle of depression is outside the triangle. And to do the trigonometry, we need an angle inside this right triangle. So this 36-degree angle really needs to be jumped down here so it's inside the triangle. And what this does is this sets up with this angle as a reference angle. This altitude is an opposite side. And this horizontal distance that we're going to be asked to look for is the adjacent side. Now this distance along this diagonal line here is the hypotenuse. So if we were asked to find the distance from the plane to the raft along a straight line, along line of sight, LOS, we'd be asked to find the hypotenuse, and we would have to use the altitude that they gave us, which is an opposite over the hypotenuse, and we could calculate this distance here along this line of sight. But in this problem, they're asking us to find this horizontal distance, which is actually the adjacent side to the raft. And we know that the plane is 3 kilometers high. That's the opposite side. So from this 36-degree reference angle, we have an opposite with adjacent, which means it has to be a tangent problem. So tan 26 is 3 kilometers, and they're using D for the distance. So D is the horizontal distance, and that's what we need to find. So we want to solve this. We would change colors. We have tangent. That's not going to show up. We have tan 26 equals 3 over D. Multiply both sides by D. D tan 26 equals 3. To find D, we divide by tan 26. D equals 3 divided by tan 26. So you could finish this with your calculator or use the table, go down the tangent column to 26 degrees, and divide 3 by the 4-place decimal, and that would give you the answer. So you can finish 21 off. If you want full credit, you need to complete this part, or you might lose a point or two. Let's do the lesson check. The angle of elevation is formed, so here's a horizontal line. The angle of elevation is formed above a horizontal line. The angle of depression is formed below a horizontal line. The measure of an angle of elevation is equal to the angle of depression because of the alternate interior angle pattern. Okay, let's look at this error analysis. So your friend, homework question says the angle of depression from the bottom of a house window to a ball on the ground is so many feet, is 20 degrees. So here's the ball on the ground. Here's the edge of the window. Here's the eye level straight out. And a 20-degree angle of depression actually puts the angle right there. That's the angle of depression. And that means that this angle of elevation from the ball to the window is 20 here. This 20 is in the wrong place. Actually, this angle here, if this is a 20 degree, since this is perpendicular to the house, the eye level, this angle has to be 90 degrees. This angle here is actually a 70-degree angle. And he had it mislabeled as a 20-degree angle because together these need to make a right angle. So if this is a 20, this has to be a 70. And this other angle, because angles of elevation are equal to angles of depression, this has to be a 20. So is the angle your friend identified as depression formed by the horizontal and the line of sight? Is the angle they identified? No, you can see that this is not connected anywhere to the line of sight. No. Is the correct angle of depression adjacent to or opposite the angle? It's actually next to the angle that he defined. It's adjacent to. Describe your friend's error. Line of sight. To ground, to ball is the angle of elevation, or the angle of depression. Depression with 2 S's. And that could probably be better worded, but hopefully we have the idea. Okay, so hopefully you can check off these vocabulary words that you understand. And you maybe rate from 1 to 10 on how well you feel you understand these concepts. Trig ratios, angle of depression, and angle of elevation. Now if we look on at the study guides, I will end up doing separate videos for these, but you need to attempt these on your own for right now. When I do the videos for these, I'll most likely do the odds and leave the evens for you to finish. So if you only copy the notes, you're only going to have half credit for this assignment, which I believe is a 20-point assignment. If you do the problems and also use the videos for the notes, or do all the problems, in other words, that's what it takes to get the full 20/20.